More? What do you need? That's nice audio. Okay, good. Yeah, room temperature. Thanks. How we doing? Good? Okay, good. Hi, everyone. Okay. Hi, remote people. What a great term for people. That's great. All right, so first of all, for a lot of you, this is the first time you've attended a talk by me. I'm a big fat nerd, and I usually stay well organized and sometimes go far astray. I really don't mind at all if people have a question, just like raise your hand, interrupt, say something. If you're remote and you need to ask a question, please just go type in the chat window and we'll have someone be able to grab your question. And other than that, we're just going to start digging into some stuff. The first thing I want to cover is just who the intended audience is for this. This is for people who are already on the C# course. That's really just it. Yeah, I have no problem at all anybody else watching the video live or watching it afterwards or whatever. It may or may not resonate with you, but I'm speaking directly to people who are already in the middle of C#. Okay. And the basic agenda is going to be this. It's about 4 different things we're going to cover. It'll be about an hour and a chance for Q&A at the end of it, right? We're going to cover the importance of C# in being a full-stack developer, what the common barriers are to learning that language and the Dotnet Framework that it's part of, what the design of our C# is, our C# course is, what the principles are behind it, which will kind of help you approach studying it and doing well, and then some specific notes, pardon me, on successful study that I've written down. So let's go dive into it. There were a lot of different languages we could have used as the primary object-oriented programming language for a school, and we chose C# for a few different reasons. The biggest one is that that's the one I do really well. Why not start there, right? You figure you can teach it well if you know it well. But one of the other reasons is that it's a very versatile language. It's used quite often for creating enterprise-grade software of all sorts of sizes. And the cool thing about knowing that language and the framework is that you can make the tiniest little scripts or the most gigantic programs that help manage multinational corporations and everything in between. Not all languages fit that kind of a classification. You guys have at this point studied about 4 or 5 languages so far. You know, there's things like the markup languages that really just affect presentation of data. And there are scripting languages that generally just operate off of those 5 basic principles we learned at the beginning of, a start point, variables, control and branching, subroutines, and an exit point, and they're very, very linear, right? And you've learned JavaScript, which has sort of a way to actually have objects in it, and can be used for a bit more things, but this is the language you hit on a program that can really be used to do everything. You can actually do almost anything with the language. I've seen C# be used to create other programming languages. They're called domain-specific languages, and usually this is for a company, and they need a language internally that will be turned into C# and get work done. You can do a lot of stuff in C#, so that's one of the reasons why we chose it. I don't have a decent timer on my laptop. I just decided to time out with it. Another reason for it is that it is an object-oriented programming language, and there's a lot of reasons why we would want to know an object-oriented language. Chief among them is that the true, top-shelf professionals in software development, that's the tool they use to make really, really great software. And while you can probably use almost any language to make almost anything, object-oriented programming languages is the one you want to use to make enterprise-grade software, and the software that pays a lot of money, which is one of the other reasons. One of the reasons we chose C# is that it's very much in demand. So it's worth learning. I'll just say this: it's worth grasping. It's a challenge to learn, and we're going to address a lot of that today. Right? Another reason to learn C#, and one reason we include it, is that it does open the door pretty well to learning other object-oriented programming languages. Once you've learned one primary language that is object-oriented, picking up additional ones is relatively easy. Or, if there are languages that aren't really primarily object-oriented, but can't implement something like it, you can grasp how and why they're doing what they're doing, even though they're not true object-oriented languages, much more easily because you've worked in a true object-oriented programming language. Another reason for teaching C# is that it's part of the .NET Framework. And working the .NET Framework is a really smart idea as a developer, in my opinion. One of the biggest reasons why is that there's a huge amount of pre-made code in the .NET Framework. It's actually very, very well maintained, written by people at Microsoft, and they do a really, really good job with it. So a lot of the heavy lifting on your software applications gets done by other people, which is awesome. So you get to benefit from their expertise and not reinvent the wheel on a lot of the fundamental things you're going to need for a lot of different programs. Another cool thing about learning a language that's supported by the .NET Framework is that, like C# of course, is that if you want to do some programming in a different language that's actually supported by the .NET Framework, making that shift is easy. You're going to operate with a lot of the same sort of concepts and programming constructs. So, for example, if you want to learn or you're given an assignment on a new job with Visual Basic, it's actually going to be relatively easy because you're so familiar with the whole ecosystem that C# exists in, the .NET Framework. And finally, another really important thing about learning both C# and the .NET Framework is it allows for rapid application development. Very, very often I've had an opportunity to be able to prototype just a basic idea of what an application's interface would look like and some of the operation of it in a matter of 1 or 2 days to be able to show a manager when they know that the actual full production of that software would take weeks or months, but they can see the concept very, very quickly. That's not always that easy with a lot of different languages. Right? And that's, by the way, one of the principal reasons historically that Microsoft even worked on creating the .NET Framework and these .NET Framework supported languages is a whole concept they had of rapid application development. So often developers were having to create on their own work that had already been solved thousands of times by other developers, and that's actually absurd. There's a concept of programming of DRY, D-R-Y, don't repeat yourself. Right? If you're going to find yourself writing something for the second time, don't write it the second time. Find a way to actually just clone it. Right? So that's a very, very bastardized explanation of the concept of don't repeat yourself, but you get the idea. So that's like the basic concept of why it would be important to learn C# as a full stack developer is the versatility of it. You can create enterprise-grade applications and everything else with it. It's object-oriented, it's in-demand, so you can get jobs and make money. It opens the door to learning other object-oriented programming languages. It's part of the .NET Framework, which brings a whole lot of benefit, and it's really great for rapid application development. Good. So, that said, why is it so hard? Because it can be very hard to learn C#. And I know this from personal experience. Learning C# was not easy for me. Okay? I had a bit of benefit in that I'd learned C, which is its predecessor, but that's about it. Basic syntax is about the same. So, a couple of the reasons learning this is hard, and I know I'm probably preaching to the choir here for those of you who are any kind of headway into the C# course, is that it's a very complex system. It isn't just that you're learning a language. When you're learning Python, there's very little overhead learned in the language. You might have to have a tiny little integrated development environment as a place to do your work, but it really is just writing as text files and go. When you're learning JavaScript, you literally are just pop open Notepad and write some JavaScript. You can work in a little teeny ecosystem with an IDE, but you just deal with the language, and that's about it. Obviously, markup languages like HTML, you just really write the HTML file, save it, paint it in the browser, you see your work. There's a huge amount of overhead and just stuff involved in C# that isn't actually C#. There's the .NET Framework itself, all these giant, massive libraries, the base class library, which covers all of the native things like basic integers and strings and all that. And then the framework class library, which is all these pre-made libraries of code for things like data access, and it's huge what's there, right? And then when you pop up in Visual Studio, your integrated development environment, and go to create new, you'll see like 15 million quadrillion different types of solutions you can make, like all these web applications and these console applications and these data applications and reporting and business intelligence. And every single one of those, when you click on one of them and create one, generates between 10 and 50,000 lines of code for you, and it can just really get overwhelming. And all you're trying to do is learn C#. So that's a problem. And then you get the fact that it's an object-oriented programming language. And in fact, it's like a true object-oriented programming language with everything that involves in terms of encapsulation, inheritance, and polymorphism, and all these things that make an alphabet soup. Okay? Throw on top of that there's a lot to the actual language. We have this tool early on in the program called Small Basic. Small Basic has 12 commands in it. Now, those commands are overloaded a lot, so you can do a lot of things with them, but there's 12 commands to kind of start with, right? How many different reserved keywords and language elements are there in C#? It's huge, right? So all this adds up to a lot of challenge in learning C#, and we know this. We know that it's the, it's the beefiest part of our curriculum. It's the one that people have to work the hardest at. And what I want to do is give a bit of background on what's the design of our course, what to expect as you go along, and some things that can help you get through it. Okay? The basic sequence that we decided on, that's most workable over time, is that first we're going to clear up basic definitions. Okay? Now, this is going to make it a lot easier because of, hold it up for the camera, we did this, we wrote the dictionary, right? Our definitions before were decent. These, we try to make them just as crystal clear as possible. And I'm going to give you an example, because I want you guys to be using this, where all the data in the courses is going to use this. Here's an example of, I'm going to share my screen so people are going to see what I'm talking about here. You guys won't, but you guys have been in the course, so it'll be fine. What I'm going to go to is like within the first 3 pages, you're going to have a big giant page of definitions to read, right? I'm not connected to the internet. Come on, really? I feel really bad for anybody who's watching remotely. And I'm going to lose this, and I'm glad we're recording it. I think it's because whoever named the internet for the area named it Ponyville. Ponyville, I don't know what it is. Really? Now the video editor's going to like this, all this dead time me talking to a computer. I'm really not getting a Wi-Fi signal, that's irritating.
Yep, I'm on it.
You're on Ponyville?
No, I'm on Tech Academy.
Tech Academy or Tech Academy 5?
Tech Academy.
Thanks. Is it a minute after 12?
No, it's 10:20.
You got me. And is 12 the numbers or spelled out? I forgot. Thanks. Thanks. Just hope that works. Let's hope these guys do all right. Okay, so you log in, pull up the first couple pages of the course. And by the way, has anybody logged into the C# course this morning? Okay. We pushed some changes last night around 11 midnight. I think we had 11. So, again, these definitions weren't wrong, but they weren't what we wanted. Like, this is the C# and ASP.NET course, right? So we define a framework. It says here, a framework is a physical or conceptual structure intended to act as a support for the general outline for something to operate in. Okay, true. Is that really what we care about in technology? Framework. In order to understand the term framework, you first have to understand the terms program and code. Programs are written instructions handed into the computer that make it perform certain tasks. Another term for programs is software. Code is the specific instructions that make up a program. They are usually written by a person called a computer programmer. A framework is a pre-made set of computer code that can be used in creating programs, along with documentation on how to use that code. Example, Microsoft offers a framework called the Dotnet Framework. It is a popular tool for creating business programs and other types of computer programs. Good, so why am I bringing this up? I've been teaching for a long time, guys. One of the biggest challenges there is to learning any subject is actually genuinely understanding the terms involved. Actually knowing the definitions of the words involved. And it's an overlooked element of education. We tried to solve that quite a bit in our program. But one of the challenges when you're trying to learn C# with the Dotnet Framework is there's a ton of new words to learn. And in the effort to just like want to get through the course or other things that feel overwhelming about it, you might be tempted to skip over these things. It's really, really, really important that you're learning proper, crystal clear definitions for these words. And if you have any confusion about them, you clear them up, okay? So part of the structure of our class, to get back to this, tips for. It didn't. The Wi-Fi died.
Oh, okay.
Yeah. I'm probably going to need someone in here during this entire period, just for technical support, because I'm not going to notice any of this stuff.
Okay.
I'm just doing the presentation.
Okay, I'll be right back.
Okay. All right. The good news is that that's recording. Okay, good. So we decided to lay out some of the basic definitions. Okay, you're going to find later on today when you log in that the definitions have been tweaked and updated, and it should be better. And I recommend for anyone who's passed page 3 or whatever of the course, go back and relook at the definitions on that first little section of the course. Okay. The next thing we'll cover is just the fundamentals of the Dotnet Framework, because it's silly to jump into learning C# as a language if you don't understand its environment, what it runs in. This is where you learn about how it is that you can write a program in one language and it'll run on tons of different machines with different architectures, different operating systems at this point, and different physical architectures in terms of the CPU and all that kind of thing. Right? You need to know what is the ecosystem that it works in. Then you need to learn C# itself. And what you're going to learn is what are the basics, like the primitive types that are involved. And by the way, the thing to think with when you're learning this is to go back to the very earlier parts of the boot camp when we laid out the 5 basic elements of any computer program. Again, I just rattled them off. There's an entrance, there's variables, control and branching statements, subprograms, and an exit. No computer program can exist without those. Right? Technically, you can have them without subprograms, but it wouldn't do very much. So when I'm approaching learning a new language, these are the things I keep in my mind is, okay, there's a lot going on here. How do I nail down just those 5 basic things? Where is the computer going to start executing this program? How do I declare a variable? How do I accomplish my control and branching if, then, else, while? And how do I create a subprogram or whatever construct this program then uses to create subprograms? And finally, does the program end execution? Well, they all do, so I won't worry too much about that. But we try to lay it out in that same manner. You want to learn some of the basic syntax, the basic primitive types that are involved. You want to learn how to declare variables and how to accomplish control and branching and loops and that sort of thing, right? And then finally, you want to attack object-oriented programming. I've seen approaches to teaching this that jump into both all at the same, all of it all at the same time, and I don't really think it works. Once you've actually handled that, now you're looking at the idea of creating actual full-blown computer programs that can be full, N-tier. Who has come across the term N-tier? Let's see how well Erik did. ThreeTier, you may have heard that. Okay. All right, this is fun. Ready? So, when you're dividing your program into pieces, because you want to divide your program into pieces and not have one giant monolithic computer program that's 15 quadrillion lines long, it's best conceptually to think of it often in 3 different tiers. Your data access layer, that's going to deal with interoperability with whatever data store you have, be it a database or a file structure or whatever. Then there's your business logic layer. This is basically, why did the company ask you to make the software in the first place? What's it supposed to do? What human processes is it replacing? You're going to put those decisions, if then else, inside that business logic layer. And it's, of course, you're going to have to interact with that data store. And then finally, there's a presentation layer. You got to have a GUI. You got to have a way for the user to actually interact with it. There are very few computer programs you're ever going to make that won't have an interface for the user of some kind. Now, it can happen. Some of you may move into like embedded system programming, where you're like building software for some physical device that you don't actually create the user interface for. But that's not what we're concentrating on here.
In the late 80s, early 90s, the concept of three-tier programming that I just described came about. Data access layer, business logic layer, presentation layer. With certain variations, that sort of concept is still one of the primary ways to think about creating a program. And there's a lot of variations on the theme, and you'll see them as you go out into the world being developers. But the central concept of dividing your code into these three areas is at work in a lot of different ways. Okay? Because of that, when you're studying C# on our course, once you've gotten to the point where you've covered the basic, all the types that are, the basic types that are built in, integer and string and all that, and you've covered the fundamentals that cover any computer programming language, like your variables, control and branching, now you're going to go to, and you can handle object-oriented programming. Now you're going to look at, okay, how do I now build something that can work with data, that can access data, and that can create a good presentation for the user? In other words, you're going to start looking at how do I create these three-tier programs. Now, I said n-tier because in algebra, n is the variable, right? The programs aren't strictly organized always into these three tiers now. There's a lot of things, a lot of different variations on this. And so another term came about 10 years ago called n-tier. In other words, what if we had 4 tiers or 5? It's up to you to divide your code however you want to, but there's this established paradigms that people agree upon, and this n-tier is a term that gets thrown around, and I apologize for throwing it out without defining it ahead of time. So, in terms of sequence of learning the language, after you've gotten past like just the concept of object-oriented programming, you'll jump into like how do I interact with the database, all with an eye towards being able to, when you're done, create these multiple tiered programs. Part of that is that you're going to next learn like common architecture of a program. Things that I just talked about. Okay, you're probably going to want to have some sort of a section where you deal with database access. You're probably going to have some sort of section where you deal with creating whatever presentation layer there is, right? You're going to learn a few of these common architectures of your computer programs kind of thing. And that isn't something we dive into much earlier in the program. Like when you're learning HTML and CSS, you don't have to come up with much of an architecture. You're going to create a web page and that's about it, right? And when you JavaScript a little bit, you might have some concept that, wow, well, I'm writing this JavaScript code and it's going to go in the browser, it'll be executed by the browser, but I can make calls from the browser down to the server, the web server. Okay, good. There's a little bit of concept of the architecture of the whole system. But when you're on C#, now you're going to dive into that and learn a little bit about how that all works, because this is a language that can deal in all those places. It can deal with data access, it can deal with all of your server-side code, and it can actually help influence what goes on in the browser or be part of the solution of sending JavaScript code to the browser to be executed. Good, so when you're done with all that, now you're actually going to go into like learning how to create web applications. Now notice we didn't start right there, and there's a specific strategy behind that, and this is just something to keep in mind while you're learning. There are training approaches that actually start full-blown with you're learning a language while also trying to, on top of that, learn how web applications work. No, thank you. Just learn the fundamentals of the language, then put it into a console where you can see it, and then start dealing with the whole business there is with web applications. Because now you're going to need to learn about, what's the full request response cycle in terms of web? And how does that fit into this specific paradigm of the .Net Framework, using the C# language, and using a pre-made framework called ASP.NET Web Forms? Notice the gradient. We don't just throw you right into that at the beginning, okay? But we do throw you into it, and you're going to learn a lot of web form stuff. And you're going to do that because there's still a lot of software out there in the enterprise area that uses web forms. Modern architecture, because this industry moves at such an unbelievably fast pace, is shifted over to the final thing you learn on here, which is another web application architecture called MVC, Model View Controller, okay? Now, notice that we get more and more complex as you move through. Well, if any of you are a decent way through the C# course, you're saying, yes, Eric, I know we get more complex, because right now I want to beat my head against the wall. There's a lot of things I'm trying to learn all at once. Okay, here's other elements of the design of our course that are there as tools for you, and I want you to understand them so you might use them a little better. We try to balance theory and practical application, and one of the primary ways we do this is There's a lot of videos you're going to watch where there's actually coding being done. You're expected to stop and write out all of the code. You're seeing, oh, I kind of get what he says right there, but then you're expected to do it, to actually apply those skills practically. And that is one, I'm going to come to this a little later in notes on successful study, but I'm going to hammer it in right now and we'll hammer it in later. Write down and do every single bit of code you see in any video or any written exercise. Do the actual coding. It's never enough, and I have to do this. I'm a senior developer, and when I'm learning something new, I have to write it. It's not enough to just go, oh, I see what he did there, and I do understand it. That's not it. Write the code. Invariably, you're going to go, well, that didn't compile. I thought I was doing what he did. And it's the lessons that are learned when it doesn't compile, when it doesn't run right, when you have a bug, those are the important lessons, and you won't arrive to those until you actually write the code and it doesn't work, and you want to beat your head against the wall. Not that I'm familiar with that feeling at all, okay? Okay, good. So we've also, and this is one of the things that just kind of got added in at certain key points, we have people write essays after all the key subjects. Like those little things I just laid through in terms of the sequence, you'll find essays in there, and they're really there to just test your understanding. I've found that if you can't explain a concept to another person well, then there's something that you don't quite get about it, right? And you're going to find that there are drills at key points. Now, I know you're like, well, yeah, you told me to write out every bit of code I see. A drill is a separate sort of thing. It encapsulates a whole concept all at once. The earlier thing I was referring to is anytime you see someone writing any kind of bit of code, just write it, even if it's a couple of lines. Even if it's just like declaring a variable or whatever, write it. It helps, I'll just say that, okay? And finally, we do a final drill and an exam just to test, you know, how well you do. But ultimately, in terms of something as big as C#, the exam and the test really is what comes next, which is you get through a quick project management course and you do a live project. So I'm gonna go a little bit out sequence on something that I have on this sort of written note in front of me, and you guys can have access to all this stuff later on if you need to. The guys who are in the room. I have a lot of understanding of some of the challenges that people go through in trying to learn this part of the curriculum. Okay, and I'm going to tell a story that some of my employees have heard before and they'll probably get tired of hearing it, but it was a very important moment for me, both as a student and as someone who became a teacher. When I was in the Navy, I was stationed in Idaho, of all places. There's a Navy facility out there that for a long time was one of the final steps in training nuclear reactor operators. And you can imagine that like the knowledge level you'd have to have and the trust they would place in you was pretty high. You're a 22-year-old punk kid operating a nuclear reactor on a ship out, you know, that could be in the middle of a war, right? So they would teach you electronics and then a huge amount of theory about nuclear power and a whole lot of other subjects, and then they'd send you to an actual working nuclear reactor. And that's what this facility in Idaho was. You're training on the actual thing, and it was phenomenal. It was a blast, except it was also really, really, really tough. And what they would do is they'd have you learn, much like we have here, one individual little system at a time. And here's what I mean. On a boat, you have hundreds of interrelated systems. There'll be an electrical generation system that sends electrical power through the whole thing. There'll be the propulsion system that spins the screws so you can actually move through the water, otherwise you're not very useful, right? There are, you know, hydraulic systems that operate all sorts of things, and there's water storage systems because people like to drink water every once in a while. There's a system to be able to pull in seawater, strip out all of the salt, and like you can actually drink, like all sorts of systems. What you do is you study one at a time, and you just learn that system, and you'd walk around the boat like tracing out where all these things were. Like if there was a pure water storage system, you'd be like literally finding the actual tank, putting your hands on it and tracing the pumps that fill it up and all the pipes that take it to different points in the boat. And it was pretty overwhelming. And like I remember 10 or 15 of these systems in, I'm just, okay, I know this data about this stuff, but I can't really think with all of it. Like, how does it help that I happen to know how this hydraulic system works to open a big giant valve? Okay, great. But I remember in particular that about 2 months in, and this is like 70-hour weeks, like intense. The Navy trains you really hard. I was doing some study on one particular system. It happened to be that one I talked about, pure water storage. I'm like, okay, we're storing pure water so that people have clean water to drink. But as I'm tracing a pipe where it hits a wall, in the Navy they call them bulkheads, where it hits a bulkhead and it comes out the other side, I'm noticing several other pipes of various things. They might hold steam or hydraulic oil, and then the one I'm tracing, and they're all there. And then all of a sudden, everything clicked. And all those other systems that some of these physical things I'm looking at represented, whether it's electrical generation and distribution, or whether it's hydraulic systems or steam systems, all these fluid systems, I understood how each of them connected to and influenced the other. And the whole ship I was on, it was a submarine, don't laugh, it was a submarine line out, okay? The whole submarine just went, whoo, in my head. And I got the whole thing. And I could think with, oh, if this thing happens over here in terms of one of the electrical generators and something changes in the electrical output, this is how it'll affect every other one of those things. It was a fantastic moment. But up until that point, I was a really, really, really frustrated student. And I'm really bright like you guys are. It was very, very tough. And in looking back on it, I think part of the challenge was the complexity of what I was trying to learn. When you're learning HTML, you can kind of grok the subject pretty quickly. Grok means to understand fully, sorry. Okay, you can kind of get the subject pretty quickly. Within probably 2 or 3 hours of study, you can get the whole concept of, well, so I'm making a language that isn't actually the content in a display. This is going to change what the content does, how it's physically positioned, its, its color, it's like, oh, okay, good. And that's going to be used by a special program called a browser so that I can create interfaces. And you can even get how it relate to the web in a couple, 3 hours. And then you're just learning the language. You're learning, okay, what's the structure of an HTML page? And what is this thing called the document object model? And how can I you can get that super quickly and easily. The aha moment can happen pretty quickly. The aha moment is not going to come within day 1 of C# or day 10 or day 20, unless you're doing 40, 50, 60 hours a week. It'll happen at a different point for each person, and it will happen. One of the chief challenges we find on this program for people that are really having trouble getting through it is being willing to experience that, being willing to experience knowing little isolated pieces of data, but not being able to put the whole picture together. It's not a fun experience for a person who's trying to understand, and not just understand, be able to apply. You guys are all learning this language so you can do something with it, so you can make programs that satisfy your boss so you didn't get fired, or that's the lowest form of motivation for it, or that build really cool tools. You're not learning it so you can say, oh, I went through a school. You want to do something valuable with it. And that moment takes a lot of work to get to. And it's one of the, really, if I had just sat down and said, hey, it's going to take a lot of work, stick with it, end of lecture, probably would be fine, because that's the principal thing I want you to get out of this, okay? But I find that people do a lot better when they understand the principles behind things, just than being told to do it, right? So, I jumped ahead to a thing I was going to have later on in the thing, but I just want to tell that story, okay? All right, so now, I am going to get into some notes on successful study, some very specific things, okay? And you guys are all going to get this document afterwards, so you take whatever notes you have, that's fine, but you'll be able to be reminded of what Erik is yammering on about, okay? The first one is actually to start with an understanding of what are called abstract data types. Now, this goes all the way back to the first and second courses you guys did on the boot camp. You all right? Okay, good. That's fine. So, it's totally fine. So, the concept of an abstract data type is really just, well, it's why computer programming languages exist in the first place. Is great, so we have this awesome digital tool that can process information. Well, the information it's going to process relates to things in the real world. Well, what are some of the most common things we have in the real world? Well, we have quantities of things, okay, good. And we have sequences of things, right? These are like these real world things we deal with all the time. And so the early programmers had to figure out a way to represent these things. But what they realized is that you have to get the concept of what type of thing is it I'm even dealing with before you make one represented in a computer In other words, let's look at the concept of a book. A book as a concept would have to contain the concept of an actual specified order to the elements in it. And what are those elements? It would have to have the concept of a written page that has the display of text. Okay, good, fine. Why is that important? Well, it's important because you have to make it so that a computer can keep track of what those things are. So what you're thinking with in terms of a data type is what's the expected behavior and appearance of a type of data, and what are the things you can do with it. And you need to solve those things mentally or on paper before you create them in the computer. A perfect example would be an array. Now, at this point in your boot camp, everybody's familiar with an array and the fact that you have elements in the array, and there's something attached to that, in the individual element, which is called its index. Where does it exist in the array? And you've probably done a fair bit of work with arrays and iterating through them and all that kind of stuff. But have you ever thought about writing down an actual description of the concept of an array? Say, like a collection of like data types arranged in a known order with attached metadata for each one that defines its position in that structure. Okay, good. You've described the appearance of that data type. And you'd also want to describe what's the behavior of it. Well, one of the behaviors you would want to have in an array is you have the ability to iterate through the array or to locate and modify a specified element in the array. Now, we take these things for granted if you've done any kind of coding because you work with a lot of arrays or collections or lists. But someone had to think of, in an abstract concept, what would these things look like and what could you do with them? Someone solved that for you guys long ago, and for me as developers. And they did the same thing with something as simple as an int, an integer. Well, what does it look like? And what's the behavior of it? They had to solve all these things ahead of time and program them. They had to say, okay, if there's an integer, well then one, you need to set aside a certain amount of space in memory in that computer. And two, you need to have a set of pre-made instructions on what you can do. What's the behavior of integers? And their mathematical behaviors, right? They said that sometimes you want to be able to convert them to strings. So we better account for that as a possible behavior. But it all had to be thought up ahead of time in terms of what's the appearance and behavior of this type of data. And it always reflected something you could observe in the real world. You could actually have, an alphabet, and you could go through the alphabet. You could have a book. You could have a library, right? Now, this is important in learning a complex language like C#, but it's also important in learning any language. The reason I'm bringing it up to you guys is this language is the one where you get to make your own types more than any other one. You create types called classes, called interfaces. But if you're not thinking with that, you're just doing something someone else did. And the tools you're using to do it, like integers and strings and all that, those are just examples of what you're already doing. It can make it a little difficult, okay? So, even when you're learning, even when you're on the first part of the course, and you're learning those primitive data types that are built in, I found it helpful to think about the fact that those things, in terms of their behavior and the actual implementation of them, are actually defined inside the .NET Framework. You can actually locate them, by the way. If you really want to drill down, you could actually find the actual code that defines how an integer works. I've looked, it's boring. We know how they work, right? All you're doing when you're writing C# programs and creating your own classes and defining what their properties are and what the methods are in them, you get to create. You're creating, okay, all right, what does this data type of a student look like? Well, it looks like an ID and a first name and a last name and a grade point average and an address, and that's what it looks like. Okay, what are the things I can do with it? What's its behavior? Well, the things I want to be able to do is enroll it on a course or assign it a grade or change its property. Oh, good. Okay. All right. And you think of all of that probably before you even write the code. That's all we got done with these primitive data types. And that's all really you're doing as a programmer. So the tools you're using to do it, especially in an object-oriented programming language, have a whole lot of things around them that make it very challenging. I remember the first time I was studying C# and boom, it pops up, you know, the method was, you know, static void main args and an array. I'm like, I'm going to sleep. What is all that stuff? When what I got like, well, it's a type, and that type is called a class. Oh, okay, well, what's a class? Well, it's a thing that you can assign how it looks with properties and things it can do with methods. And it's got this added thing that you can make another thing that looks just like it, but can add or modify it. Whoa. It can get complex, I get it. But at the end of the day, that's all you're dealing with is what's the abstract idea of what this thing I want to create in a computer looks like and can do. And that should probably help you sort your way through, you know, classes and interfaces, right? Okay, good. So that's a little bit of note. Start with, and if you need to go back and review this stuff on really understanding abstract data types, go back to the overview of software development course. I believe that's why I put the video on it. It might even be back in the computer basics course, and watch the video I have on abstract versus implementation, okay? All right, second thing, and I already stressed this, I'll stress it again. Do every single bit of coding that you see in a video or on paper. Do the actual coding, okay? And if you're having difficulty with a certain bit of it, right, and it didn't seem very smooth to you, then do the coding again and change one thing. Just change the output of the string, like whatever string you're throwing to the console. Just change a thing. I've used this technique over and over again. Here it is on the paper or on the screen. First step, get it to work like Joe on the screen does. Whoever's writing it, right? Okay, good. Solve that. Solve my semicolon or whatever it was stopping it. Okay, good. It runs. Go in and tweak one thing. See what error message you get if it doesn't work. See how it does work, and that's awesome. In other words, you have a known working installation. And this is an approach that I've found very valuable in any programming endeavor. Find a version of whatever you're dealing with that works. You don't have to understand all of it, but it works. And then go in and change one and only one thing. It's a huge error I've seen people make. They think, well, I know what this change is going to do. I'll just make this go faster by also changing the thing I really want to check. No. Change one thing. One thing. And then change it and then run it. And you can learn so much by why it broke, why it failed. And eventually you'll write several or 3 or 4 or 5 or 10 of them and go, wow, I really get the creation of a method. Creating an overloaded method. You do them over and over again. So the actual note here says, if you're having a bit of difficulty with a concept, do the coding exercise several times, varying parts of the code to see what happens, okay? Don't be like nervous about just mucking around with the code and messing around and just like, what happens? You're not gonna break anything. All right, and this is, here's another one. This is probably the course where you might want to utilize the take a walk concept fairly often. I get it, man. There's a lot here. When I was learning MVC for the first time, it's a whole different way of thinking, right? Who here is through most of like the web forms videos where you've actually, you've created a lot of the solutions on web forms? Okay, good. About half of you. Good, excellent. Okay. Of those, has anybody gone on to MVC already? It's a whole different beast, isn't it? Like it's a whole different way of thinking of how the browser can take a user action, where it sends it down inside the server, what happens, and how eventually HTML comes back to the server. Now that's a pretty basic concept. We covered that in courses 1 and 2, honestly, of the boot camp. That user action in the browser, a request goes to the server, it does whatever, searches out an HTML file and sends it back. But there's a lot of ways to accomplish what goes on in the browser and on the server, and MVC is an odd construct to get. I found that once you get it, you'll love it. But believe me, I wanted to take a walk. First, I wanted to bang my head against the wall, and then I wanted to go take a walk, right? It's fine to do that. It's good to get some space and some separation from stuff, okay? So utilize that. It's okay. Don't feel bad about like, man, I'm really not getting this. Expect many moments like that on the course. Do whatever you need to do. Take a walk, drink a cup of coffee, whatever you got to do, okay? And again, understand that you likely won't get it until you're a ways through the course. Prepare yourself for that. I'm not saying it's going to be easy to experience. I had to learn the whole thing at one point, and it was not easy. And there are elements of it, even now as a senior developer. When I say it, I mean C# and the .NET Framework. Then I'm like, I kind of get the concept. Honestly, it's huge. It's massive. No one ever uses all of it. But enough people use different sections of it, enough different sectors of the programming world that Microsoft maintains all of it. But no one uses all of it. And it can be very intimidating. Okay, here's another very valuable practical tool. If you're in doubt about a thing, you're having trouble with it, try to explain it to an instructor. Say, hey, listen, help me out with this. I'm going to try to explain polymorphism to you. I'm probably going to muck it up and look like an idiot. So let me do that, please. And then grab a whiteboard, or if you're a remote student, do a screen share and just draw it out and show him and explain. What happens, like I said earlier, is if you can explain something comfortably to someone else where they get it, man, you're golden, okay? If you hit a wall in drawing it on a whiteboard, sketching it on paper, explaining the concept, very often, one of two things will happen. You're going to solve it right then in that conversation. Or two, you're going to spot the exact area where you're like, I actually don't know how that works. It will be an uninspected area. It'll be an area that you kind of thought you knew all about. But the way to find those isn't to keep drilling in and writing the code and getting frustrated. It's just to try to explain it to someone else. It's one of several tools you can use, but I found it really valuable. Because it happens for me. I was like, oh, I get that. I'll get some very complex sort of like business requirement from a client, right? And I really think I got it up here. Everybody in this room and listening is pretty bright and able to hold relatively complex systems and concepts in their mind. Systems that they can even track their changes over time as different inputs happen. Like, we're all really bright. So you might think you got it. Prove it. Write it down. It's so worth taking the time. You also build your own documentation for whatever you're doing, which is great because it's right there on paper, okay? And then if you find a thing this way that you don't quite know, don't be embarrassed to go back and restudy. One of the things we find challenging as instructors here is that many of us are used to this academic world where you get made wrong for not getting a thing right off the bat or for asking questions. This is also a story that my employees have heard too many times. But I earned a very, very well-deserved reputation in Naval Nuclear Power School for asking too many questions. So much so that instead of giving my job description as ET3, which is Electronics Technician 3rd Class, my job was DQ3, Dumb Question 3rd Class. I don't care. I'm fine. I graduated in the top 10% of the class because I was willing to ask those dumb questions. What's the definition of a dumb question? There's no such thing. How could there be, like, if you're genuinely trying to understand and you don't, it's dumb not to ask the question. That's my point of view. And I'll never call you dumb because I like people. But frankly, like, come on, if you don't get it, what are you doing just going past that? You're not doing this, and I know you guys know this. Again, I'm preaching to the choir. You're not doing this class and this boot camp to pass a test. You're doing it to pass life. In other words, you go out on the job and you can actually do it. And if you can't explain it, if you're in doubt about something, the responsibility level you have to raise your hand and go, I'm actually not quite getting this, it's huge. In fact, the responsibility level you have to do that is actually equal to the responsibility we have to get you through the program. And that way you've got 100% responsibility on both sides, so it's going to happen. Okay? All right, final thing. Said at the beginning, and say it here, make sure you don't go past any misunderstood words. It's critical. You can either take Erik's word for it, or you can learn your lesson the hard way, but don't do it. If it's this dictionary, or an online reference, or just sit down and talk it through with an instructor like, I don't understand blah, I'm not going to throw them out because I might give you a misunderstood word, right? And even in this little presentation, go back. Get what I have here. Watch the video. If there's because I'm speaking to you guys as people who have been through a big chunk of our program. And I know I threw out a lot of different terms. I tried to define some of them as I went along, but there might be ones you don't get. learn them. Right? My instructor's gonna be mad at me. Recursive functions are phenomenal, and they're very, very valuable for hierarchical data structures, like a structure chart for a company, or when you have different product lines in a company that have sub-products under them. You need a way as a programmer to dictate going down one avenue of that, coming back up, and then going down another. That kind of an approach. Remember the idea of a data structure with what does it look like and what's the behavior? One of the behaviors you're going to want for a very complex hierarchical data structure is, how do I traverse that, find a specific point of data, and then come back up to the top? You're going to want to know that as a programmer, right? You do it with recursive functions. I think I'm going to do a seminar on recursive functions because I see a lot of blank stares. This is awesome. Good. So again, make sure you don't go past any misunderstood words, right? And if our definitions aren't adequate, let us know. If there's some that you come across all the time, like, really, you guys throw this term around and it's really not covered, let us know. It's important to us. But the responsibility is also on you to go, man, I actually don't know what that word means. I better clear it up. I do this in everything I study, but in particular with programming languages, because there's a lot of technical terms. Okay, now I'm going to make a special announcement in a moment, and then after that we're going to have a Q&A. Okay, so for those of you who are currently on the C# course, which is obviously the vast majority of the people who are in the room and are watching online, you guys are going to be granted an additional 4 weeks to go through the C# course. Okay, it's a big deal. Normally we'd actually charge about $1,000 to be able to do something like that, right? You don't need to do anything on it if you're already on the C# course. All the records internally in terms of our instructors and the learning management system have already been updated on this overnight, so that you actually just have 4 more weeks to get through things, okay? You don't have to notify an instructor. It's just there for you. Now, for anyone not on the C# course, I just want to let you know, because some people, anybody in the room not on the C# course? Okay, good, cool. And probably, watching remotely, you don't have to worry about this in terms of like, wow, am I going to have any trouble getting through it? I've actually already taken action to be able to do things to speed up the course. This can help everyone. People who are currently involved on it, enrolled on the course, and anybody who's going to arrive to it later on. And probably it'll actually work out even better because you've got this talk and you know the approach to take in terms of diving in. For those of you who are already mid the course, well, you guys have experienced some of the things I've talked about, and hopefully this will help you, okay? So that's it in terms of the actual presentation, but I want to open the floor to anything, any questions, anything at all. I really do mean that thing about there's no such thing as a dumb question. And so anybody wants to ask me anything, go ahead. And for people that are remote, if you can type it in the chat window, then Kendra, you can help forward on questions. Okay, good. All right, go ahead.
So there are two kind of the same questions. What are the updates to the C# course, and when will they be?
Good, excellent. The updates are implemented, and here's what they are. The big giant chunk of videos that you watch that Bob Tabor does, first of all, there are about 4 or 5 of them that were literally just not needed. They're just extraneous. I mean, it's not stuff that's horrible to learn at all, but you don't really need them. Like, this next thing I'm going to say is true for any computer programming language. The random function for any computer programming language isn't really random. Sorry, it's not. And there's a lot of cool geeky computer science stuff you can study about why true random functions don't exist in computers. But he has about a 5-minute video on why the random function isn't random. For us, it's enough to know, hey, random functions aren't truly random. Study up on it if you want. Okay? So that's an example. It's about 4 or 5 videos that got taken out. But one of the biggest things we did is, you know how Bob builds this little cheat sheet along the way as you're going through the course? That's fine. I like it. I like taking notes on stuff like that. He has a video for every single one. You don't need that. We've taken out the requirement to watch every one of those videos. And what we put in there instead is, hey, at the beginning of the course, you get the whole cheat sheet. There it is. So when you get to that section, all you do is review that section of the cheat sheet, and it's already there for you. It's going to save you some time. Okay? Because that's one example where it's not really that big a deal. You don't need to be typing that. It's a text reference document. Yeah, I kind of thought that as well. Yeah. And here's the other thing is, at every key chunk of concept, we're asking you to write an essay. And you're like, wait, that could add time. This is the important thing we found. We want to spot early in the program on C# where someone's understanding starts to go awry. There's so much to learn that if you get too far into it and you've got some central misunderstanding, you have to roll back through a lot of data, find it, and then a fair bit of data might need to be restudied, get reoriented with your new correct understanding. With something as simple as HTML, maybe not that big a deal, but a big deal when it comes to something like this, okay? So you'll find essays at every key point where you explain in your own words the central concepts that you just covered. And it's just one more way of like putting into the program those tips I just gave you about if you can't explain it to someone else really well, something's wrong. Go back, restudy, get help from an instructor, you know, that kind of thing. So those are the changes, and those changes are live right now. The one change didn't get done overnight and will be done this afternoon is that those definitions I talked about on, I think, page 3 or whatever of the course, they need to be switched out for the definitions from the Technology Basics Dictionary. That's all. That'll be done within, might even be done right now while I'm in this presentation, okay? So for reviewing those, this is just for people already on the course. I would wait until tomorrow or later this afternoon. We'll let you know. Just go back and review those definitions. I think there's like 8 or 10 of them on that page, but it'll probably help to have them better defined. I hope that answers that question for the remote person. Okay, good. Is there another remote question? We will.
There's a couple, yeah. Will learning the .Net Framework help with .core?
Yes. Brilliant question.
From Sandy.
Okay. So will learning the .Net Framework help with learning .core? Absolutely, 100%, period. Like, the .Net Framework is this big giant collection of pre-made code, right? .Net Core is a collection of pre-made code that's platform independent. When you write in that, it can run on a Python machine, a Linux machine, or a Windows machine, or a Mac OS machine. So the shift is smooth and seamless because you're using the same exact concepts of there's a base class library that defines all my native types like integers and strings and all that. There's a framework class library that I get to use with all this pre-made code, and I'm writing in whatever language I like, C#, Visual Basic, whatever, you know, it's a .NET compatible language. So it will totally prepare you for that. Others?
Yeah, I remember some of those.
Yeah, it's totally fine. We've got a virtual monopoly. Get it? Virtual monopoly. Okay, sorry. Anybody in the room have questions?
Erik, are you available to answer questions if we get stuck and the instructors?
Yeah, there's a student policy. There's a policy for students on that. The short answer is yes, after it's escalated through the structure of the company. And we put that in place for a very specific reason. I had to think long and hard about this because, look, when we started, like, think about this, 3 or 4 students, Erik and Jack, I am the instructor and answer everything. And I love that role. You can't expand a company like that. We have 220 enrolled students. I can't be the instructor for everyone. So what we found is the way to build a thing effectively and multiply yourself in terms of ability to do good work and build an organization is that where there's something that we didn't cover well enough in the curriculum that it generates, you know, a good number of questions, then that rolls up first to the instructor, and if they can handle it and then recommend a curriculum change, then we do so. If the instructor can't handle it, it rolls up to the director of the entire academy, who would be one of our senior experienced instructors and developers. And if they, you know, they would answer it and recommend a change to the curriculum so it doesn't come up again. And if it really doesn't work there, all the way up to the dean. Right now, I'm wearing the dean, you know, job. So the answer is yes, if it rolls up that high. And if we find stuff like that, I actually am overjoyed because it means there's something we didn't catch that now we caught, but it rolls through that system. So probably a long-winded answer of yes, but I want you to understand why it isn't that, like in the first couple of years, people just walk up to me and talk all day long about computer. You know, I wish it could be like that, but you can't build an organization that way. So I try to put as much of me as I can into the program, so that's good or bad, depending upon your point of view. Any other questions or anything?
I got one.
Yeah.
So you said, just to clarify, you said you're going to give us an extra 4 weeks. Is that to the C# course?
The C# course, yeah.
So you basically doubled our time to learn C#.
Mm-hmm. Yeah.
Pretty awesome.
Boom done.
Thank you.
Thank you. Yeah.
I appreciate that.
Yeah, absolutely.
Thank
Yeah.
you very much.
And I also, obviously not straight to me, please, but I want feedback on, you know, the things we put in there in terms of, you know, value for you and like whether they help, that kind of thing. Let's see. Yes.
So the follow-up to that.
Yeah.
And I'm about 180 videos into the 200 or so videos.
Yeah.
And I kept watching the bar scroll across, getting closer to 100% while I'm going nowhere.
Yeah.
I felt
You're gonna love this.
Yeah,
Go
I
ahead.
felt a lot of pressure to, okay, I kind of get it, I'm clicking on, and I haven't done all that coding. I've done bits and pieces of it.
Yeah.
But I'm kind of swimming.
Yep.
So would it just make better sense, given this extra time, to kind of go back at the beginning and maybe not watch everything again, or watch everything again, or how should I reapproach C#? I guess?
Okay. Brilliant question. I appreciate it. Right. And there's a caveat to this, which is the advice I'm about to give you. I need you to coordinate with your instructors, so it's not just Erik coming down straight way down the organization and just bypassing everyone. I don't want that. Okay. But I can tell you that it's a really, really good idea to do that. Okay. So there's two things on that. One, in terms of the progress bar, you're gonna love this.
I hate your progress.
I know. Oh yeah, absolutely. Well, look at that. You're like, there's 40 flipping videos on the Bob Tabor thing in this one step, right? It's all broken up into about 17 chunks now. So as you go through these chunks, your progress bar will actually indicate, oh my God, I'm getting somewhere. It's so interesting about progress bars. If they're not moving, even though you're learning, you feel like. And I understand that. So the progress bar will be accurate, right? But yeah, you'll also find it, you aren't just dealing with one big giant beast of, oh my God, I'm still on the same step. It is broken up into chunks. But yeah, to answer your question, it's a highly good idea to go back and do that, okay? I think you'll find it easier to do so. Obviously, you're not even going to be looking at those, the cheat sheet review videos, right?
And some of the early ones are pretty obvious, and they're
Exactly.
repetitive to some degree of the other
Yep.
materials. So.
Absolutely. So this is a point where you'll be able to actually utilize some of the things that we're talking about here today, where one, you can look for misunderstood terms as you're going through it and go, oh, I actually didn't get that along the way. Clear it up right then. It'll be awesome, right? And two, you'll get a lot more actual writing of the code. And I think you'll find that things will come together really quickly at that point, because you can't fail to absorb a great deal of it. And it'll just make it more concrete. That's a good question. And I'll go for
You're
that.
not really forced to write at all, and you're kind of just eyeing the time, and you're
Yep.
yeah, okay.
Yeah, exactly. So it is a pause, write what he did. That's how I do tutorials all the time, guys. I have to stay abreast of all the new technology that's out there and try to predict as best as possible what it is that's actually going to stick in the marketplace to figure out whether we actually bring it into the curriculum, so I'm preparing people well. So I have to do these things all the time, and it's the same exact routine. I sit down, I find one I look for decent writing in the actual written elements around the videos or whatever, right? And then I actually just do all of the code, and I don't try to vary it. I don't muck around with, why don't I think about something I could build for the school with this? No, do the tutorial to learn they already solved all of the weird things that always come up whenever you're building a new application. Don't add that randomness into what you're doing. Just do what they did. And I write all the code. I write every lick of it, right? It's the only way to actually learn these things, in my experience, when it comes to really, really complex programming languages. Anything else? Yeah.
For students who have already moved a good portion of the way through, like the 7-video course, would it be necessary to kind of roll back to catch the new changes to the program?
You can if you want to. It really is. It's sort of the same thing there. It's just make sure you communicate with the instructors about whether you're going to do it or not. Here's the thing is, you have the extra time now. You know what I mean? Like, the time is there, and you won't have to feel like oh my word, I'm messing everything up because now I'm going to be overdue and like all the problems that come with that. I do recommend it. Here's the thing: if you guys take the time to really, really learn C# well, you're never going to want for a job. I'll tell you that. And you're going to enjoy the live project a whole lot more because you'll actually be able to really contribute and get it. So yeah, that would actually be a pretty good idea. But again, coordinate with your instructor. So, because I don't want Daniel to come be yammering at me. Yeah.
If you do MVC, would you mix learning C# and MVC, or just focus more on C# first and then go on to MVC? That way you're not doing a little bit of MVC like at night and C# during the day or something like that.
Oh, like if you want to do some self-study kind of thing?
Yeah. Would you recommend that, or just say, hey, put MVC to the side right now?
I put it off to the side. And this is just the,
Could you ask the question?
yes, yeah, for sure. He basically asked the question like, let's say you're doing some study of MVC like on the side. I mean, we have some at the end of the program, but let's like, if you're intrigued by it, and look, I love inquisitiveness. It's awesome, right? But the basic question was, let's say you're doing something like that, studying MVC, and you're doing it off to the side. Would you recommend actually holding off on that a little bit till you're through actually learning C# as the subject? Or would it be fine to just kind of study that stuff? I recommend you wait, okay? And only because of this, like, okay, there's this thing we talk about in some of the enrollment videos and that kind of stuff early on about the approach we have being a bottom-up approach rather than a top-down approach. And these are loose terms that the education industry throws around. But the basic thing is, when you're learning something brand new, are you going to throw them in to the actual thing they're going to be working with? Like, let's say you're learning this language Ruby. Bam! You're learning to code using Ruby. And you're writing code instantly, right? And along the way, hopefully you'll learn things like, well, like the abstract concepts of what is it that every program has in common? It looks like they all make use of variables. There's a few constants, but mostly variables. There's some sort of control and branching thing. They all sort of make use of that. And there's some sort of methodology for creating repeatable chunks of code that can be called over and over. You could probably, if you were bright, glean all of that abstract stuff pretty quickly, right? But what if you didn't? What if you just learned Ruby and that's all? And you were adept at Ruby. And then what if Ruby went away, which has happened in the Portland marketplace? It's not as needed anymore, right? Now, the next time you go to learn a new language, you may or may not have grasped some of that abstract senior data about programming. That's why we do it the way we do, it's bottom up. Build the foundations for the conceptual understanding of what you're about to embark upon, and then look at a practical implementation of that, an implementation of a programming language. This is why you would want to do it this way, is that you learn the fundamentals of operating with that language and that framework and a web application framework, namely web forms. And then you hit MVC and go, oh, 8/10 of this I already get. I get the .Net Framework. I get a web application framework. I know that it's got all these built-in things for routing and handling requests, for error handling, for rendering the presentation layer, right? What's different about this? That's where I can concentrate my learning on, right? Now, I will say that once you guys have been out in the marketplace for a few years, you're mid-level developers, senior-level developers, you can actually take a top-level approach and just dive right into learning a new technology and not have to worry about some of the fundamentals, usually, right? That's how I do it now. But it's because there's so many things that I now understand that I can very quickly isolate. What the heck is that? What is this language doing? I've never seen a thing like that. And I can just concentrate on that one little thing right there, like when I was studying Angular, right? This front-end framework called Angular. Like, all right, I get model view controller because I know that really well. And obviously, I get the concept of a browser being able to execute the code because I've worked a lot with JavaScript in the browser. What's weird about this? Oh, it's these terms. I'm not going to throw them out because, again, it'd be misunderstood terms, right? But what do those terms mean? And I just drilled right in on a very specific technical aspect of this Angular framework and learned what it was. And then I was able to actually work with it really well. Not an approach a beginner should take, but you guys will get to the point where that is an approach you'll probably enjoy. That's a long-winded answer.
Sure.
Wait on the MVC.
Thank you.
Other questions?
One other quick one.
Oh, yeah, sure.
I'm a part-time student,
Mhm.
so is it 4 weeks for part-time students as well, or?
I'll have to clarify that. I'll find out.
Yeah.
Good question.
Eric, do you think it would be helpful to pair program at all for any of us doing the C#?
I'm not sure. Did the remote guys get that? I'm not sure how well the microphone picked up. She's asking, do you think it'd be helpful to pair program for any of us on doing the C#?
If we're at the same level? Or...
I don't want to introduce that element in without a controlled look at how it would go. There are plenty of programs around the country that utilize paired programming. Okay. Now, to be completely blunt, in all my years of programming, I've had one place that implemented paired programming, and they did it on a very, very part-time basis. There are other shops out there that apparently do a lot of paired programming. I'm like, this is my reality. This is my opinion, labeled thoroughly as an opinion, okay? I really have enjoyed paired programming only under two circumstances. When I've done it with a really experienced developer who's on a par with me and can communicate really well, it's a blast. It's like you learn so much so fast. You really get how another person thinks and approaches things. You learn like that, like liquid. Or when I'm mentoring someone. And it's not really paired programming, but it is, you're both in there. You do it. Okay, good, awesome. Oh, okay, good. Well, here's what I would, that kind of thing. Long story short, I haven't looked at like whether or not to introduce that as a stable element of how we do the training here, right? It's something we're willing to look at. What I'd say to you is if you're having challenges on any aspect of getting through this or another course, first try this, because this we've worked with and we know does get the job done. And if you're still bumping into anything or really just feel a need for that, just talk to an instructor and say, hey, I really actually would like the idea of doing some of this with another person, and we'll see what can be done on it.
Yeah, makes sense.
I am the king of long-winded answers today.
No, that makes sense.
Did someone else have something? I wasn't sure. Any remote questions?
No.
Okay, cool. All right. No, yeah, please.
Is there a book that you would recommend to read while going through C#?
It's tough. It's really tough. The answer is no.
Okay.
Yeah, just do the curriculum. Like, let me show you something.
He was looking at that.
I love this book, but I'm an experienced developer. That's who this book is written for. But it doesn't really say that. I'm just going to show you something here. I'm going to end off in a few minutes, okay? No, I'm not going to do this to you guys. All right, I'm not even going to say the words. All right. So you start to read this, right? And let's say you're relatively new to the subject. Maybe you're like you guys are, and you've gone through quite a bit of boot camp, and you've learned some things along the way. The philosophy of .NET. Every few years or so, the modern-day programmer must be willing to perform a self-inflicted knowledge transplant to stay current with the new technologies of the day. That's very, very true. A self-inflicted knowledge transplant to stay current with the new technologies of the day. I love that. But then he says, and this you're trying to read this and you're a relative beginner. The languages, blank, 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 frameworks, blank, 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 architectures, 5 more blanks, and APIs, 4 more blanks, that were touted as the silver bullets of software development eventually became overshadowed by something better, or at the very least, something new. So you're reading a book, and by the way, 90% of the blanks are completely outdated, deprecated technologies that were in use in the late 90s and mid-2000s. Now, for an experienced developer, he can totally relate. Like, oh yeah, you're right, I remember that's gone the way of the dodo. No one uses that anymore. It'd be laughable if you proposed using that, right? His point is made really well. For a newbie, you'd be like, I don't know, any of that stuff means I want to go to sleep now, you know? So, very few written materials that address something as robust and powerful as the C# programming language. Don't make that mistake. They're experienced developers. That's who can write these things. It's not written by a newbie. And so they are primarily writing to that person, and they can make these references and drop these terms and have a reasonable expectation that their audience is going to get it or be well equipped to quickly look it up and go, oh yeah, because that's like blah, 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 blah. It doesn't work for me. It doesn't. So, no, don't. Does that help? Okay, good. Anything else? Yeah, it's totally fine. We're here, but we have 8 more minutes, by the way. We need to clear out at 11:30. And I'm totally fine on questions. So you and then you.
Cool. One last question.
That's a dumb question. Okay.
Okay. If I've taken a good portion of the C#.
Yeah.
Obviously, I'd probably say I've only kept a portion of it. A lot of it's gone over my head.
Mm-hmm.
So going back with this extra time.
Yeah.
It's all important to know. I know.
Mm-hmm.
But where should I focus? Where do you think I should focus on the Bob Tabor videos to get the most, in your opinion, out of it?
Object-oriented programming. Because here's the thing. At this point of the program, you guys aren't going to have any problems with dealing with for each loops and declaring variables of type integer and making an array. But object-oriented programming is a bit of a different beast. That's where I would put my attention on. Okay, that and things like data access and working with the web application framework itself. Just because primarily you guys are going to be building applications that are in some way, shape, or form related to the web. It's just that's where everything is nowadays, right? So just as advice, the more different projects and languages and frameworks that you can do that relate to web applications, the better. Because again, it's just where things are. And you're going to start to see commonalities between all these different web application frameworks. Even on this course, when you move from web forms and then study MVC, you'll see, oh, there's a bunch of things that they both have to do and that, thank God, are built in for me. Things like, how do I route an incoming request? How do I get state data for a specific object from the database? How do I handle authentication? Making sure that this user is actually allowed to access this stuff. A web application framework that is worthy of being called that is going to have a bunch of this stuff built in. And so then later on, you might be studying Python. And there's a wonderful web application framework there called Django, D-J-A-N-G-O, right? And you can look at it and go, oh, well, look, it has a methodology for handling incoming requests and routing them to the right, server-side code, server-side method. It's got a methodology for handling errors, right? It's got a methodology for authentication, all built in, out of the box. I can just click a button and boom, there it is. And you're gonna start to see, you're gonna know what to expect every time you hit a new web application framework. Now that can be true for a lot of frameworks, but most of the time you're gonna be doing a lot of work for the web. Good answer. I'm gonna do that handle.
Oh yeah, that's pretty good. I was just hoping on video.
Yeah, I know. And you had a question?
Yeah, I was wondering why you've chosen to have us follow the Bob Tabor videos versus the in-house made videos that were in previous portions of the curriculum.
We're still recording, are we? Well, I left directions that the part that's going to be recorded for posterity and for future students ends right before the special announcement, because obviously the special announcement is for you guys who are currently on the C# course. You want to know the truth?
Yes.
We're not done making in-house C# videos. It's a massive undertaking. It's taken us 2.5 years, and we're not done. Look at how much gets covered. More importantly, the lessons we've learned over like a 5-year period of what's the best way to do this, the program has to encapsulate all of those. So what I know to be true is that we do get a great product with what we have. Bob can drone on a lot, and sometimes he puts personal comments in his videos and racka, okay? But he knows his stuff. It's just, we do know there's a better way to do it. And so what we've done is, with things like this, like making sure that we put in, correct definitions and the right gradient and all that kind of stuff. But that's why. It was an almost insurmountable task. But we're doing it. Yeah, it'll be out eventually.
Are you doing videos?
Nope.
Shortest answer.
We actually, we got extremely lucky. Just as an aside, do any of you remember Jesse Johnson? It's been about 8 months since he was employed by the school, but he was actually running the academy for quite some time. We went through the whole boot camp, and talented developer, worked on a lot of our in-house stuff, and just there are very few people who can explain technology concepts as well as I can. It may sound like bragging, but it's a very true statement now at this point. It's been 25 years, and I can explain technology stuff pretty well, right? He's the best I've ever found besides me. He's phenomenal. And I've seen some of the product he's creating for us. It's fantastic. It's really, really good. So if I had my druthers, I would be the one making them. I love to make these. I love this stuff. You know that, right? But I have a lot of other duties, and so I got to make other stuff. I wasn't able to make those. Sorry. Or not sorry, depending upon whether you guys are sick and tired of seeing my face. Other questions? Yeah.
I guess as a follow-up, what about the students who finish the course before that material is released?
Which material?
The material that's in development.
No, there's no prediction on when that's going to come out. You guys are going to be fine. And the thing I do want to point out on that, and I understand like a bit of the think behind it is like, well, if there's a better way to do it, God, that'd be great. If we get it from Erik or someone else, that'd be great. The thing I want to point out is that we get product. Just to be very pragmatic about it, our developers, our graduates get hired, and we get repeat business from companies. In other words, you can feel confident in the outcome of it, right? There's always improvements that can be made to any system. There's always there's a better way to do a thing. And if you're not paying attention and constantly iterating and improving what you're doing, then you're not being professional. So the ultimate obviously would be to produce that. But then look at that for a moment. Once that's produced, we're going to find things that need to be improved about it. There can be changes to the language. It's an iterative process, right? So I legitimately want to give you confidence that you're going to be fine if you get through this program, the C# class, right? Do your project management course really quick and just dive in and be an active participating member on the live project. That's actually where it really does come together. It's like, you're never going to remember all this stuff, guys. It's just not going to happen. I was talking to Sean McRae, one of our students, a little while ago. He's like, I feel like I can't remember all these details on C#. I'm like, yeah, I can't. Like, come on, there's so much stuff there. But can you learn how to think like a software developer? Do you understand that there's a base class library and a framework class library and a bunch of pre-made code that you can kind of take advantage of? Do you have a basic concept of the fact that you can have a solution that has namespaces where you kind of categorize your code, and that you could, inside that code, it could be set on a server, a web server, and it could bang a database and get some data back, and you could create some sort of HTML to send to a browser. And can you work within that framework? You're fine. You're just fine. Part of the reason it can be daunting to jump and go, wow, I'm going to call myself a C# developer, is because you're like, well, wait a minute, I signed 9 million things on that course. I'm not a C# developer. I can spell it, right? But that isn't actually the primary product of it. It's, are you familiar enough with the ecosystem of C# and the Dotnet Framework that you can actually navigate it afterwards and kind of find the solutions? That's all I do, and I write tons of C# code. Obviously, it goes a lot faster, but only because I've done a lot of it. The same basic thinking process is at work when I'm doing it, which is, oh yeah, connection strings. Hate connection strings. We all do, right? Connecting to databases. There's 4 or 5 different ways to format connection strings inside of the .NET Framework, depending upon whether you're using some sort of depending upon the way you access data. I'm not going to give misunderstood words again, right? I don't remember all of them. No way. Every single time. SQL Server connection string C#. Google it. Every single time. But at least I know that there's 4 or 5 different varieties and that you need to choose the right one. And I know inside of it, there's usually instructions as to authentication for how to hit that SQL Server database. I know that stuff. The exact syntax of it and whether it changes, whether I've got my computer program deployed out on Azure in the cloud or it's local on a server in the company, I don't remember all that. I don't need to. No one does. If you're going to try to do that, you eat a bullet. It's insane how much data there is. Just learn how to think like a developer. Learn the basics of how the C# language works. The basics of fundamentals of object-oriented programming language, and write a fair bit of code, and then get onto the live project. Just get onto the live project. It actually doesn't even matter what task you do on the live project, whether it's just something as simple as making changes in the user interface, or hardcore as, well, there's a server-side C# code, like these methods that I have to completely reconfigure and pull them over into a different area, whatever it is, what you're actually going to learn is, oh crap, I can actually operate as part of a team, and I can get a task done, and I can do this. So again, this is just the think behind how we put this program together, and when people approach it knowing that that's the think, and that they aren't expected to just know everything, the outcome is better, and you approach the job search process with the right sort of viewpoint. Does that make sense? 11:33. Unless there's something super important, we should probably end off. Anybody from any remote? Okay, good.
Thanks.
Okay. Oh yeah, absolutely. And this is for the people in the room and for people remote. I really appreciate it when people actually take the time to come to these things. we talked a lot about the pressure involved in trying to get through these things, and you guys paid a lot of money to go to this, and we have a huge responsibility on our end. You guys have a huge responsibility on your end. So the fact that you would take an hour and a half of your time to sit down and go through this, I sincerely appreciate it. So thank you all very much for doing this. Let's look at the 18 million calls and texts Erik got. Oh my God.
Can we get this book?